This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The third formula we need to prove is the cosine formula. A squared equals b squared plus c squared minus 2bc cosine A. In order to prove this formula, we're going to have to draw a little diagram for ourselves. So the first thing we do is to draw this triangle we have here, where the angle A is placed at the origin, 0, 0, and the side C is placed along the x-axis, this side here of length C, which means that this point out here is C in the x and still 0 in the y. Then we have a circle here which is b times larger than the unit circle, which means that the x and y coordinates will also be b times larger. So in the unit circle, you remember we had a radius of length 1, and in the x we had cosine A, where A is this angle here, and in the y we had sine A. But in our case now we have a radius of b instead of a radius of 1, so each of these values here, b cosine A and sine A, will be multiplied by b. So that means that this point up here on the circle has coordinates b cos A in the x and b sine A in the y. So now when we look at this diagram, we have 2 points. We have the point C0 from out here. We have the point b cos A, b sine A from up here. And now we use the distance formula from coordinate geometry to get the distance between these 2 points. So you'll remember that formula reads that the distance between 2 points, which we've called here A, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So in our case, our x2 is equal to b cos A, our x1 is c, our y2 is b sine A, and our y1 is 0. So filling these values into our formula, we get this line here. And if we square both sides, we'll get an a squared on the left, and the square root will disappear on the right. And then we just have to follow through. We multiply out these brackets inside. So this bracket here, this squared here, must be multiplied out. So that would be b cos A minus c times b cos A minus c. So when we multiply out that bracket, we'll end up with this line here. And we'll have a b squared sine squared A coming from this squared. And then it's just a matter of tidying things up. So we have a b squared sine squared A here and a b squared cos squared A here. If we just group those two terms together here for a moment, leave the plus c squared and the minus 2bc cos A at the end, then what we can do between these terms here is take out a common factor of b squared, leaving cos squared A plus sine squared A in a bracket here. But then we need to recall that cos squared A plus sine squared A is equal to 1. So that means this whole cos squared plus sine squared A that is seen here changes into a just multiplied by 1. So we end up with A squared is equal to just B squared plus C squared minus 2BC cos A, which is the formula we were looking for. And we also have a QED there.